moest wachten. Maar we hebben nu ook de livestream going. So I will say welcome to those who have logged in to the livestream. With the two laureates that are here, who are English speaking, we agreed that I would do the introduction in Dutch, because then the families at home can see what Dutch sounds like. So sorry folks, that's all it's going to be today. Ik ben Louise Gunning en ik sta hier als voorzitter van de Koninklijke Hollandse Maatschappij der Wetenschappen. En dat is een van die geleerde genootschappen uit de verlichting, waarin wetenschappers en leden die maatschappelijke posities hebben in publieke of private sector bij elkaar komen om te zorgen dat de ideeën van de wetenschap tot bloei gebracht worden in de samenleving. En dat doen wij hier al sinds 1752. En intussen is het een heel groot genootschap geworden. We hebben denk ik zo'n 400 wetenschappers en 400 maatschappelijke leden, die we directeuren noemen, die onderdeel uitmaken van de Hollandse Maatschappij. En een paar keer per jaar komen we bij elkaar voor een lezing. Maar van oudsher is de hoofdtaak van de Hollandse Maatschappij om prijzen uit te reiken. Prijzen voor wetenschappers op elk niveau in hun loopbaan, om ze te eren als ze iets bijzonders gedaan hebben en vooral om ze aan te moedigen om verder te gaan. Dus wij hopen altijd dat prijswinnaars terugkomen. Als ze een prijs gehad hebben voor hun afstudeerscriptie, zien we ze graag terug voor een proefschrift. En gisteren hadden we hier een oeuvreprijs van Ed van de Heuvel, de sterrenkundige, die terugkeek op een prachtige loopbaan. Dus that's all ahead of you. U bent hier in het Keetje Hodshon huis, genoemd naar degene die het heeft laten bouwen, Keetje Hodshon. U moet zich voorstellen, eind 18e eeuw, een jong meisje, wie beide ouders overleden zijn en die een fortuin krijgt. En van dat fortuin besluit ze een stadspaleis te bouwen. En dat is dit huis. Ze heeft toen de beste architect uit die tijd, Abraham Hart, gevraagd om het mooiste huis wat hij kon maken volgens de absoluut laatste mode hier neer te zetten. Dit is misschien wel de mooiste kamer, de blauwe kamer. En u ziet dat helemaal in de stijl zoals het hoort. De 4 jaargetijden. Dus als u ergens vanmiddag een beetje de draad kwijtraakt, kijk dan en raad wat is. Maar zorg dat de spreker het niet merkt. En natuurlijk de symmetrie die er aan beide kanten is. Achter mij 2 ramen met in het midden, 2 spiegels met in het midden een raam. En als u achter zich kijkt, 2 deuren met in het midden een spiegel. En dan kan ik ook verklappen dat die linkerdeur geen echte deur is. Die is er alleen ingezet voor de symmetrie. Nou, als u zo meteen nog de gelegenheid hebt, kijk, aan de overkant is de bibliotheek en we hadden net thee in de bestuurskamer. En u kunt zich voorstellen in welke stijl Keetje Hodshon hier leefde. Ze is nooit getrouwd. En ze heeft hier altijd alleen, met natuurlijk heel veel personeel, geleefd. En daar gaan prachtige verhalen over waarom ze nooit getrouwd is. Nou, ik houd erbij dat in die tijd wettelijk je fortuin naar je echtgenoot overging. En zij dacht, mij niet gezien. Ik doe het zelf. We gaan vandaag ook een paar van die namen terugkomen in de 3 proefschriftprijzen die we uit gaan reiken. Het zijn grote prijzen. Meestal hebben we niet zo'n groot bedrag, €12.500, voor 3 proefschriften die zich echt met kop en schouders boven de rest uitsteken. En de reden dat we zulke mooie prijzen kunnen uitreiken is dat de Ruigrok Stichting degene is die deze prijzen voor ons sponsort en ook hier mogelijk maakt. Wij zijn ontzettend trots op die samenwerking, want het zijn 3 heel bijzondere prijzen. En ik wil heel graag op dit moment het woord geven aan Ton Tekstra, de voorzitter van de Ruigrok Stichting, om iets te vertellen over de achtergrond van de stichting die deze prijzen mogelijk maakt. En u hebt gezien, ik ben niet zo goed ter been, ik heb een spierziekte, dus ik ga zo meteen zitten. Maar gelukkig hebben wij 2 voortreffelijke wetenschappelijke secretarissen, Ad IJzerman en Wim Drees, beide hoogleraar in hun werkzaam leven, die zullen zorgen dat de prijsuitreiking in goede banen geleid wordt. Ik hoop dat het een heel inspirerende en spannende middag wordt. En ik verheug me al op de praatjes van de laureaten. Tom, mag ik jou...
Ik ga de microfoons iets omhoog doen en hoop dat de camera's er ook... ik zie daar een geruststellend gebaar achterin, dus ik ben in beeld, ook voor de kijkers online. Dames en heren, ook hartelijk welkom geheten bij deze prijsuitreiking middag door de JC Ruigrok Stichting. En Louise zei het net al, ik mag iets vertellen over de achtergrond van de stichting. Daar valt heel veel over te vertellen. Als jullie er meer over willen weten, kunnen jullie naar onze website toe gaan. Even heel kort naar het begin. Wij hebben een bestuur van 6 bestuursleden gemiddeld, waarvan het merendeel hier aanwezig is. Brigitta de Gruyter zit hier we zijn achterin Vincent Brandon, Eelco Martens als onze penningmeester _CFO. En Wilmar Geerdink, even kijken, Wilmar. Ja, hiernaast. Ik zit achter een hele grote meneer, dus ik zag je niet meteen. En last but not least Bernard Elsinga, die vanmiddag namens de Ruigrok Stichting de prijzen ook gaat uitreiken. De Ruigrok Stichting is gestart in 1977 doordat meneer Ruigrok, J.C. Ruigrok, Johannes Cornelis Ruigrok, bedacht dat het vermogentje wat hij vergaard had met zijn onderneming in de hekken. Jullie zullen je, denk ik, zie al mensen knikken. De beste banner is ongeveer dat je een hek ergens hebt staan waar je naam op staat. En dat is ook zo. Ruigrok Hekwerken zien jullie vaak terug. En dat is het bedrijf wat meneer Ruigrok had. En die heeft het vermogen ondergebracht in een stichting. En die heeft daarbij een paar dingen gezegd. Ten eerste dat vermogen zeg maar even kan worden besteed aan goede doelen, noem ik het maar even, maatschappelijke doelen in de regio Groot-Kennemerland. Wat is nou Groot-Kennemerland? Dat is Haarlem en omstreken tot het Noordzeekanaal, zeg ik maar eventjes. Dus Spaarndam en zo valt daar ook onder. En de noordelijke Bollenstreek, dus Lisse, Hillegom, Noordwijkerhout. En dan uiteraard ook de Haarlemmermeer. Dus dat is de regio waarbinnen wij ons begeven. Aan de ene kant. En vervolgens heeft meneer Ruigrok gezegd, nou het moet ook binnen bepaalde domeinen, zoals wij dat dan noemen, bepaalde gebieden. Nou probeer ik even uit mijn hoofd te zeggen, maar nogmaals, kijk naar de website als jullie het precies allemaal willen weten. Maar dat begint met zeg maar een sociaal-maatschappelijke doelbesteding. Cultuur uiteraard. Sport en beweging valt daaronder. Ontwikkelingssamenwerking. Wat wij inmiddels noemen levensbeschouwing, wat vroeger dan de religie en andere heette levensbeschouwing. En last but not least ook de wetenschappelijke kant. En daarmee zijn we ook bij de middag waarbij, nou ik geloof iets van 15 jaar geleden, we hadden het er nog over wanneer het precies was, de J.C. Ruigrok-prijzen zijn ingesteld. En wij het eigenlijk sinds jaar en dag prachtig vinden om daarmee jonge wetenschappers in het zonnetje te zetten. Ik wil nog een andere club in het zonnetje zetten, dat is de KHMW, die al die tijd ons op een fantastische manier ondersteunt. Met een geoliede machine noem ik het maar even, maar er zit ongelooflijk veel werk achter, dat zullen jullie wel kunnen voorstellen. Commissies die worden ingesteld om al die mooie proefschriften te beoordelen. En nou, daar gaan we straks ook de laudatio's over horen. Dus nogmaals veel dank KHMW. Maar we zijn hier vanmiddag, we are here this afternoon, voor de laureaten, as you are called. De prijswinnaars. En ik zou zeggen, ook voor jullie een hele mooie middag en alle andere aanwezigen. En ik hoop dat het ook met Louise een hele inspirerende middag wordt. Dank voor jullie aandacht.
Dankjewel, Ton. Ook de toelichting over de JC Ruigrok Stichting en de prijzen die we vanmiddag gaan uitreiken. Ja, dan wordt het tijd voor de eerste prijs al. En dat is de Martinus van Marum prijs. Dit jaar op het gebied van de exacte wetenschappen. En daar staan dan onder wiskunde, informatica, natuurkunde en sterrenkunde. Martinus van Marum ligt ons heel erg na aan het hart, de KHMW, omdat hij de tweede secretaris was ooit. Hij is in 1750 geboren, dus hij kon het begin 1752 niet echt bewust meemaken, maar al snel was hij een Haarlem een gezaghebbende persoon, die ook zeer ondernemend was en al spoedig betrokken was bij de oprichting van Teylers Museum, dat is hier aan de overkant van Spaarne, maar ook bij deze maatschappij, de Koninklijke Hollandse Maatschappij der Wetenschappen. Hij was zeer ondernemend, zei ik al. Als je naar het Teylers Museum gaat, dan zie je daar een enorme elektriseermachine. Hij was degene die hem ontworpen heeft en ook de financiën bij elkaar gekregen heeft om hem inderdaad uit te laten voeren, het ontwerp, en te positioneren in dat Teylers Museum in Wording. En ook voor de maatschappij heeft hij ongelooflijk veel gedaan. Hij reisde door heel Europa, was lid van alle belangrijke academische genootschappen in Frankrijk, in Engeland en ook in Nederland. Kortom, een hele mooie naam voor een hele mooie prijs. En degene die hem dit jaar wint, die staat dus in een lange traditie met een grote reputatie. En die winnaar is Elham Fadali. Ze zit hier op de eerste rij, zoals alle prijswinnaars. En bij een prijs hoort een laudatio. En we zijn heel blij dat een van de juryleden hier is, professor Tjerk Oosterkamp. En die gaat nu de laudatio uitspreken.
Ja, en ik ga dat in het Engels doen. The jury of the Martinus van Marum Prijs of 2023, it convened after looking at a considerable number of PhD theses. So these are small booklets that we study. And also recommendation letters, because people have a once-in-a-lifetime bright student. They write the best letter they can write, and they send it along with the thesis to us. And then the jury concluded, whoa, these are wonderful theses. This is the proof that this is an important prize, because people take so much trouble to send a beautiful letter along with the thesis. And generally speaking, you can say that the jury, it will look for a thesis that is exceptional in maybe, of course, the quality and the thoroughness and how well it is written and how appealing it is. And then a winner may stand out because they combine experiment and theory, which is very special. Or a thesis might stand out because it has a very original finding that no one expected, or a very creative work. Or sometimes a thesis wins a prize because it solved a problem, and a problem that, especially if it is a very important problem for society, or a problem where people have tried to solve it for a really long time. And then sometimes you win because of this. This year was different. Because we've had, as a jury, we thought, what is different this time? Because these theses were all so wonderful. So we thought, okay, maybe it's because of the pandemic. I mean, the pandemic obviously is very devastating in many ways. But for some people, maybe this time of solitary confinement means no distractions. And so we were trying to, from the quality of these theses, maybe for some people the pandemic drove them to concentration or higher level or something that no one else can. So some people have become very productive. And Among the nominated theses, there were several theses that combined theory and experiment in an exceptional way, or that stood out because they solved an important problem in a really creative way. And then we could see how proud these supervisors were and from the letters. This year's winner is Dr. Elham Fadali. At Eindhoven University of Technology, she has worked on changing the crystal structure of silicon germanium. I write, we all know silicon. If you take sand and you remove all of the oxygen, some sand results in silicon. And it's very important for much of our technology. Our computer chips are silicon. But its cubic crystal structure prevents this material from emitting light. Despite people trying really hard to make this material that is very important to emit light. And Dr. Fadali has realized the growth of really high quality silicon germanium for the first time in a hexagonal structure. So cubic and hexagonal is very important differently. This required a deep understanding of the crystal growth mechanism. The crystals need to grow from a template nanowire by a catalytic process, and there's a germanium shell around this wire. And it had to come from a gas. In addition, Dr. Fadali showed efficient light emission up to room temperature, which is, of course, an experiment. And this high efficiency of light coming out was unexpected from theory. So here comes the voila surprise. The work of Fadali has demonstrated what was missing in the theory, and it was the randomness of the different types of atoms, that the randomness resulted in this high efficiency. In addition, Dr. Fadali has revealed a new type of crystal defect, which is like studied for 200 years, and no one finds something new if something exists for such a long time, but in this new material system. And she studied this in great detail. These findings, combined with the fact that the light emission has since been shown to also act as a laser, this may be expected to really have a long-term impact on the industry. And Dr. Fadali has co-authored a foundational patent on this topic. I mean, that should have been in my list of things that make a thesis stand out. It was not even on my list, no. Dr. Fadali's work on the demonstration of direct bandgap emission from silicon germanium alloys in the hexagonal phase has generated a lot of attention in the professional literature. And while this is not so common in her field, she was invited to give several talks at international conferences during her PhD, so before being a doctor. Her work has been proclaimed the breakthrough of the year by Physics World in 2020. She has appeared in popular science magazines and in radio and in television interviews, including one in BBC. I mean, that is our big example. We would all love Dutch television to be like BBC. Okay, the jury hopes that this prize will encourage Dr. Fadali to continue her outreach and exert her influence as a role model, as she indeed has done already in her discussions with a number of ministers in Egypt on the position of women in science, which is very dear to all of our hearts. So this prize is also meant as an encouragement for very special people. We conclude that Dr. Fadali is a very, very, very exceptional winner of the Martinus van Marum Prize 2023, and we wish her all the best. Congratulations.
Thanks, Chair. Yes, please. Thanks for the quite exceptional laudatio. Thanks a lot. Now, this is the moment, I would say, and I'd like to invite Professor Bernette Elzinga and Dr. Elham Fadali to step forward and come to the podium. And then Bernette will say a few words, and There will be photos, etc.
Yes, so that was really excellent, and people who are here for the first time may notice. Oh, actually, I can switch to Dutch, but hoe fantastisch het is om hier ieder jaar te zijn. Dus het is ook dit jaar weer een enorme eer om hier te spreken namens de Ruigrok Stichting. En inderdaad, ik kreeg ook al de indruk bij het lezen van cv en presentaties te zien dat we hier inderdaad wel een exceptionele prijswinnaar hebben. En ik wil nog even, voordat de prijs komt eraan, uw geduld wordt een beetje op de proef gesteld, maar ook dank aan de mensen die in de commissie zitten. Er zijn heel veel proefschriften, misschien juist inderdaad door de coronatijd, extra veel proefschriften voorgedragen. En ik weet ook als commissielid wat een enorme werk het natuurlijk is om al die proefschriften door te lezen, te vergelijken. Wie verdient nou echt die prijs? Dus ook al zitten mensen thuis, enorm veel dank voor deze inspanningen en de kritische blik. En soms geeft een prijs net een zetje de goede richting in, maar soms geeft een winnaar ook een beetje glans aan een prijs. En dat is misschien nu wel het geval. U gaat uw prijs meenemen. U komt via België, Eindhoven, maar nu in Silicon Valley. En heeft net al kunnen horen als ze daar vragen, what is this Martinus from Marum Prijs? Dan kunt u zeggen dat dit een Groningse geleerde was uit 1750. En die net als u een hele mondiale blik had en gepassioneerd was over de wetenschap. Nou, er is al veel gezegd, dus ik hou het kort. Ik moet zeggen, wat ik heb geleerd al, even me verdiepen, kort in uw werk, is dat dit ook heel erg hoopvol is. U heeft laten zien hoe ook meer energiezuinig, dat dit allerlei mogelijke toepassingen heeft in uw doorbraak. Dus dat is denk ik ook heel hoopvol voor de toekomst. En tegelijkertijd ook hoopvol voor vrouwen in de wetenschap. Dus ik zou u nu niet langer meer op de proef stellen. De Martinus van Marum.
Thank you so much for the very nice talks and the very nice compliments. Sorry? Okay. I'm a bit short. Sorry. Thank you all so much for the very, very nice compliments and talks. I truly appreciate it, and thank you for the very prestigious prize in this prestigious place. Thanks a lot for all our honorable guests, esteemed Dutch Royal Society committee members, friends and family, being here to celebrate this very precious moment for us. Today I'll try to simplify as much as possible my topic. Okay, so as Professor Oosterkamp said, that my PhD thesis was about the epitaxy of hexagonal silicon germanium for light emission. So what it is, just in more simpler words, I'm a material scientist. I was mainly trying to fabricate one of the novel materials that have been long theoretically predicted to be very promising for light emission, having lasers for data communication. But it has been there since 70s, but it was just a theory. And it was not really experimentally realized, so this was my PhD thesis, and it's mainly towards having silicon-based lasers. And silicon, as we said, it comes from sand after some purification, and it's actually the brain of all our smart devices and all the technological advancements that we are witnessing nowadays in our life. So, what it is, so imagine we are living in the era of big data. With the huge amount of data we're generating every day, we're transmitting a lot of data, right? So can you imagine the digital footprint we are leaving through all our online activities, the huge amount of streaming via the different, like Netflix, Google, all of these stuff, we are really generating a huge amount of data. There is a huge amount of data traffic that actually pressing a big need nowadays to have faster speeds, right, but still with, how do I say it, efficient energy consumption. That's why all our technological advancements have to keep up with the pace, with the ever-increasing demand for more and more data traffic. So it's great. However, with this huge data traffic, we are also generating a lot of heat. We're consuming a lot of power, as you can see in the background. So this is one of the data centers that really handles this traffic across continents. So it heats a lot. That's why you can imagine it needs to be cooled down such that we can handle this enormous amounts of data. And if we look to the energy forecast until 2030, actually almost 21% of the world consumption comes from data centers. And you can imagine even the 50% of this 21% is actually dedicated for the cooling of the data centers. So it's an urgent need for us to look for more power efficient, still keeping up with the fast speeds of data communication to handle our traffic. So then what is the problem? The whole idea is that our conventional electronic device or electronic circuits that at the heart of our devices, we manipulate information, or the information flows in electrons through the metal wires that you can see here, like these metal wires across the different parts of our computers. And as we flow more and more information, it heats up due to the electrical resistance. And this is the whole bottleneck. So can we do it in a different way? This has been the great effort of scientists and the research over the past few decades, that they are trying to deal with data communication via optical interconnects, complementing the electrical interconnect. So we're not really trying to replace it completely, because it's doing great with the very miniaturized devices that we're having in our smart devices or laptops nowadays. But at the very high speeds, the data centers, cross continents, as you can see, for example, optical fibers, like cross continents or so, this is via the optical communication. Then, okay, it's simple, magical. We do that with the optical interconnects. But it's not that simple, because our electronic chips is based on, as Professor Osterkamp said, it's silicon and germanium. And these materials, despite being very powerful and having superior electronic properties, they are very poor optical materials. That's why we cannot use silicon, which is used for the electronic chips, for optical communication. So how do we do then our optical communication? We depend on other class of materials. We call it from the periodic table group 3-5 materials like indium phosphide, gallium arsenide, and they are excellent optical properties. But the problem is that this group of materials is not compatible with our current fabrication technology and the state of the art. So we are literally, how we're doing it nowadays, we're literally gluing a piece of the 3-5 on top of the silicon if we want to deal with the optical communication. But still, this is not the perfect solution for it. So what we are hoping for, if we can combine both functionalities, the electronic and optical functionalities, using silicon. And over the past 5 decades, it was the holy grail of the microelectronics industry. So this was exactly my thesis. It's a man on a moon mission. I need to solve that in 4 years, but of course not alone, with great collaborations and my colleagues in the group and a whole consortium of European universities, and with my professors, we actually managed to approach the problem a bit by bit, and of course with all the great research that has been in the literature that we are building on. So it's not a one-man effort, it's really a collective effort from the society that we are trying to do that. So how do we get cubic, hexagonal structure, although in nature, in sand, it's cubic? So imagine with me how the silicon structure looks like. So imagine these balls are atoms. So if we have the first layer here, we call it layer A in silicon. And then layer B, we place it on the voids in between the A atoms, right? So the third layer, we can put it on the other voids, because we have two places of voids. So we put it here as layer C. So this is structure where you can see A, B, C. Every layer of atom is a bit displaced and they are not really on top of each other, like aligned. Then we call this as the cubic structure. And this is the structure that does not emit light. So then how the hexagonal structure looks like, the whole unique property here comes in the third layer, which is C. So C here was in the other place of the voids on top of B, and then A here is actually aligned on the first layer, which is the original void. And this is the hexagonal silicon. So can you imagine that the whole different physics is really lying into the atomic arrangement in the structure, and then same material, same chemistry, it's just different physics, different electronic properties that can make such material very promising. And then it was predicted to emit light. So it's all theoretical prediction, but can we realize it first experimentally? And then can we prove, if we realize it experimentally, that it emits light efficiently? So just also to make it easy for you, how did we solve the problem first to deal, how do we realize it experimentally? So imagine if we pave the platforms in the street. So we just start with a template at the very beginning, so we agree on what is the shape we want to pave the platform with. So we start with a template, like here. So we chose, for example, if you choose this arrangement of the bricks, and then the following layers will follow, right? So as if our template is the gray here, and then our following layers are the red. And then if we choose a different arrangement, like the zigzag arrangement, so it's gray here, then everything else will follow as in red. So imagine the cubic is the ABC that I showed you here, and then this is the ABA, the zigzag structure. It's the same in our material. And the whole unique technique we used, it was already devised in our group of Professor Backers in Eindhoven University in 2012. It's called crystal transfer technique. We literally transfer the crystal via template to our silicon germanium material. So we're having a hexagonal nanowire template, and hexagonal here, the arrangement of atoms. So we call it a core nanowire. And then we overgrow it, so we flow the silicon and germanium atoms to take the same hexagonal structure of the nanowire. And then we get it like that. So how do we actually force atoms to arrange in this way? Because by nature, every atom will just fall into place to its natural or conventional structure. So we did it with a technique called epitaxy deposition technique. So by having our sample or substrate, and then we flow the atoms in a gas flow of molecules and atoms, and then the final material in red here will follow the same arrangement, let's say, of the substrate. That's why we call it epitaxy, which is from the Greek word epi, above, taxis, and an ordered matter. And to do that, we do it in a reactor, and we control it via temperature, the pressure in our reactor, and also the ratios or the percentage, for example, of our atoms in the big flow, like how much of silicon versus germanium versus the carrier gas of flow that goes and deposits on top of our substrate. So here, this is a real electron microscope image. On the left here, you can see our thin hexagonal core nanowires, and they are very thin. It's like 50 nanometer. So imagine here, the scale bar is nearly 1,000 times thinner than human hair. It's super tiny, and then we're even manipulating the atoms inside these cores. And then we overgrow it with the silicon germanium shells on the right image here. And again, you can see that they are ordered such that you can even see the crystal facets, and it shows a signature of that, okay, we are getting a crystalline material that's giving hope that, okay, we are going in the right direction. So how do we make sure that we are getting the hexagonal structure, not the cubic? So we did a transmission electron microscope. It's even higher magnification to really see how the atoms are ordered. So on the left here, which is highlighted in blue, you can see the zigzag, the ABA structure of the core template nanowire, and then highlighted in red here, this is the silicon germanium atoms. And you can see they are almost following perfectly the order of the core material as shown in the cartoon here. The red atoms are following the blue and green atoms of the core. So it's great, voila. We have a clean material, defect-free, high quality, but does it actually emit light? So this is what we have been doing. So we take our nanowires, we shine light on it, so we excite our electrons there, and then we let it relax, and then we see the emission of the light coming out of it. Does it really show efficient light emission? Is it really the correct wavelength or not? And indeed, we have seen light spectra. As you can see here, these peaks are all the signature, or not the signature, it's actually the light emitted out of our nanowires, and by tuning the percentage of germanium and silicon into the composition, then we get different colors, different wavelengths, where you can use it for different channels for transmitting or for the data communication. So this great results, and it has been shown for the first time. So what's next? Next, we need to fabricate a real laser, like seamlessly integrated in a real silicon, and then we can go forward to have, let's say, chip-to-chip communication, having this light source on our chips, and we're not having to glue like pieces on top of each other to achieve these silicon integrated photonics. how can we benefit from it in our life? You can see like in data communication, as I said at the very beginning, gas sensing for the environmental conditions monitoring, and wireless RF distribution, health monitoring for biosensing, so sensing the like certain signatures of molecules, right? And chemical sensors, also in ranging applications like LiDAR. So it's all like based on lasers that sense light, that senses the surrounding objects, and then for autonomous driving. So with that, I conclude the very brief description of my PhD work. Thank you all.
Thank you very much for this wonderful presentation. I hope it worked well for a very diverse audience. And thank you, of course, for presenting her the award, Professor. I made too small van Beden. We now move to the Keetje Hodshon Prijs. Well, I don't need to introduce the person because she has already been introduced as the woman who built this wonderful house. Maybe I should make a comment about the previous jury member. He talked about booklets. Ik kan het ook in Nederlands ook, geloof ik. Boekjes. De geschiedenisprijs, denk ik, dat niet alleen boekjes had. Dat is typisch een vakgebied waarin het stevige boeken zijn. Dus die jury heeft wat dat betreft niet alleen een groot aantal, maar ook behoorlijk stevige boeken moeten bekijken. We zijn ze daar dank voor. Mag ik professor Van Balen, oud-directeur van het Centrum voor Parlementaire Geschiedenis in Nijmegen, uitnodigen de laudatio uitspreken.
Geachte dames en heren, de dissertatie van Dr. Catherine Frederick, maar ik weet nu Dr. Kate Frederick, over de invloed van economische globaliseringsprocessen op de katoenindustrie in Oost-Afrika is een uitzonderlijke prestatie. Het is niet alleen een gedegen empirisch onderzoek over een deel van de wereld waar de bronnen niet rijkelijk voorhanden zijn, maar Frederick levert met dit onderzoek ook een belangrijke theoretische bijdrage aan een centraal debat over de drijfveren en effecten van globalisering in de 19e en 20e eeuw onder economisch historici. Door een zeer zorgvuldig vergelijkend onderzoek binnen Oost-Afrika en daarnaast door ook oog te hebben voor tegengestelde ontwikkelingen in West-Afrika in de periode 1830-1940, laat Kate Frederick overtuigend zien dat bepaalde aannames eenvoudigweg niet kloppen. En dan gaat het zowel om de aannames in de marxistisch geïnspireerde dependentia-literatuur, met als meest recente lood het alom geprezen boek Empire of Cotton van de Harvard-historicus Sven Beckert uit 2014, als om de meer marktgerichte neoclassieke literatuur met een nadruk op factorkosten. Vertegenwoordigers van beide, dus zowel van de dependentia als van de neoclassieke literatuur, hebben namelijk veel te weinig oog voor de dynamiek van de Afrikaanse markteconomie en de agency van de Afrikanen, die gedurende de hoogtijdagen van het imperialisme te maken hadden met de forces of globalization. Deze forces of globalization werden onder meer gekenmerkt door een massale import van goedkope textiel. Het blijkt niet zo te zijn dat landen in de Global South, zoals India en Egypte, na de Amerikaanse burgeroorlog het slachtoffer werden van wat Beckert noemt war capitalism, waardoor de inheemse productie van katoenen weefsels niet meer concurrerend was. Deze benadering, net als de neoclassieke, is veel te eenzijdig en te simplistisch. Maar deze benadering heeft lang kunnen gedijen bij gebrek aan vergelijkend empirisch onderzoek. En verder levert de dissertatie ook een bijdrage aan een verwant debat, namelijk dat van de Great Divergence, dat zich toespitst op de vergelijking van economische ontwikkelingen in Europa en China, en waar Afrika nauwelijks een rol in speelt. In haar zeer helder opgezette boek toetst Frederick de nooit onderzochte aanname dat de forces of globalization Afrika de das om hebben gedaan. Er blijken echter niet alleen binnen Afrika grote interne verschillen te bestaan, maar cruciaal is dat Keetje laat zien dat de meeste aannames, ik zei het daarnet ook al, eenvoudigweg niet kloppen. Zo kreeg met name West-Afrika te maken met een grote import van goedkoop textiel, maar zorgde dat daar eerder voor intensivering van de inheemse industrie dan voor een afname. Naar veel van de geïmporteerde textiel was namelijk nauwelijks vraag, vanwege onder andere preferenties van de Afrikaanse consumenten op het gebied van smaak, kwaliteit, waardoor het substitutie-effect met het inheemse aanbod beperkt was. De kwaliteit van de eigen productie was vaak veel beter, terwijl de factor arbeid juist werd aangewend in periodes dat er weinig ander werk was, waardoor de marginale kosten laag waren. En import van textiel vond plaats in regio's waar sowieso al veel vraag was naar dat soort producten, door een relatief hoge koopkracht, zoals in West-Afrika. Kortom, door haar focus op lokale condities en lokale adaptatie, oftewel agency, laat Frederick zien hoe beide linkse en rechtse grand theories mank gaan. Het hoeft dan ook niet te verbazen dat zij binnen de zeer competitieve wereld van economische historici vorig jaar zomer de dissertatieprijs van de International Economic History Association in ontvangst mocht nemen. Haar onderzoek kan daarmee worden gezien als een wake-up call voor een nieuwe generatie historici om met een heel nieuw perspectief nieuwe wegen in te slaan en weg te geraken van de veel te deterministische theorieën die nauwelijks oog hebben voor tegenkrachten en lokale en regionale mechanismen. Mevrouw Kate Frederick, graag feliciteer ik u namens de gehele jury van harte met de Keetje Hodshon Prijs 2023.
Dank. May I invite you to stand up? Professor Bernard Elsinga. Oh.
Yes, so thank you very much. Hartelijk dank voor de mooie onderbouwing, de laudatio van uw bijzondere proefschrift. We gaan van de nanometers naar Oost-Afrika, 150 jaar geleden. Het is een sprong, maar even fascinerend. En wat ik interessant vind is eigenlijk ook dat er een overlap is met de periode van Keetje Hodshon. Dus het jaar dat zij is overleden, het jaar daarna in 1830 tot de periode 1840 is precies de periode die u heeft bestudeerd. En er is ook nog een overlap in dat het fortuin wat is door de Hodshon-familie is vergaard. Dat was ook in de textielindustrie. Dus het is een hele passelijke prijs. Ja, ze waren een doopsgezinde familie en in die tijd mochten zij geen overheidsambtenaren zijn. En dus waren ze vaak in de handel actief. En in deze familie, in het linnen met name. En er was dus een groot fortuin vergaard. 7 miljoen als je het zou vertalen naar deze tijd. En daarmee is dus dit prachtige pand onder andere. Ja, exactly. Dus, we hebben al een prachtige laudatio gehoord. Nog een excellente onderzoeker die de prijs zeer toekomt. Dus ik wil u graag de prijs overhandigen. Heel erg gefeliciteerd. looking forward. All right. So I have to say, tough act to follow because I am not solving all the world's problems, but telling what I think is an important historical story, which has a lot of implications for the way that we think about Africa today, and specifically East Africa, which is still one of the most underdeveloped regions of the world. So I think that the sort of history here is quite important in its own right. But I must say that I feel even more honored to be here after hearing about the wonderful work that you are doing. So, first of all, I do want to thank the committee for indeed reading all of these, not boekjes, but huge books. I can imagine that is quite an undertaking, so thank you for your work. And also to the KHMV for this wonderful, honor. And the, do I say it right? Ruigrok Stichting for supporting this endeavor. I think this is really, really remarkable. And for all of you for being here. So as you can see from the title of my dissertation, this is really about textile production in East Africa. And it's really nice for me to be able to be talking about this again because this is really something that has kind of gripped me for really about the past decades since I actually did my master's also on topics of deindustrialization in sub-Saharan Africa. So it's wonderful to be able to talk about this again and I think really discuss some things that I think are very important for contemporary development issues. So you might be thinking, why is deindustrialization in East Africa so important to study? Well, if as a historian I think back to the British Industrial Revolution, for example, or the more recent catch-up of East Asia, basic handloom technologies have served as a springboard to broader economic and industrial development. But in the case of East Africa, we did see that these handloom technologies developed, but they didn't lead to this broader economic growth experienced elsewhere in the world. So it's important to understand why, because this has important contemporary implications for development. So this brings me to the central research question that I investigated in this dissertation, and that is when and why did handicraft cloth industries in East Africa decline? And you've already heard a bit about this from Carla, who I have to say I think has described my dissertation better than I ever could, so thank you. But as you've heard, this is really a sort of old question. This has been sort of revisited many times, especially since the 1970s, with this kind of invariable assumption that this had to do with cloth imports from abroad. It doesn't matter if you're hearing the Marxist story or if you're hearing the neoclassical story, the line kind of remains the same, that imports from industrializing parts of the world, in the US, in Europe, even in India, must have destroyed textile industries in Africa, not only East Africa, but this assumption is made for the rest of the subcontinent, or the continent of sub-Saharan Africa as well. But the issue here, as Carla has mentioned, is that this assumption is made with very, very little empirical data. This is really where my research comes into play, which I'll discuss in just a moment. But to give a little bit more background on this idea of dependency theory, which has really been quite dominant in ideas of deindustrialization for quite a long time, before the neoclassical scholars came in a bit more recently. And this really was sort of popularized in the 1970s. And basically the idea is that as Europeans especially started to develop a taste for raw materials in places, produced in places like Africa, they started exporting machine-produced cloth to these regions in exchange for those raw materials. And as more and more imports of machine-made cloth gets into Africa from places like Europe, that just sort of drowns out the local industry. There's also a sort of argument that this whole process is sort of furthered by coercive colonial policies as well. But the sort of really central line
is that imports are what destroy local industry in East Africa. So I wanted to know if the story remains the same if we actually bring in quantitative material. And I have to say that coming into this, I really didn't know what I would find. You know, I didn't set out to sort of disprove these scholars, and I didn't set out to prove that they were correct. So it was kind of a blank slate. And what was really exciting was that I was kind of surprised at every turn. And the story turned out to be a lot more complicated than we assume, which always is very exciting finding for a researcher. So I started to collect quantitative material first to actually get a sense for how much cloth was entering Africa, because we didn't know that yet. And of course, this is really the first step. You need to know how much cotton cloth is entering this region to know if it's causing a problem. So I collected trade records from the 3 largest exporters of cloth to sub-Saharan Africa during the 19th and 20th centuries. This included shipping records from the United States, as well as records from India and the United Kingdom. And when all of this trade data came together, a kind of curious pattern started to emerge, which immediately began to undermine these assumptions that cloth imports were killing off local industry in sub-Saharan Africa. So what we're looking at here is a graph of per capita cloth imports into both East Africa and West Africa. And what we see is that cloth imports into East Africa were actually substantially lower than cloth imports into West Africa. And this is really crucial because actually West African cloth industries were much more resilient than East African industries. They actually thrived during the 19th and 20th centuries, and even today, textile producers continue to supplement their incomes with cloth production. Meanwhile, in East Africa, there is a lot less cloth being imported, yet it's here that we see this decline and really disappearance of textile manufacturing already by the 19th and 20th century. So this really doesn't fit the assumptions that have been made for so long. And if we zoom out and take a longer term temporal view, which of course historians love to do, we see that the period in which textile manufacturing was disappearing in East Africa, which is indicated in this red box here, well, this actually was long before we see imports per capita reach what we would consider to be a bare subsistence minimum of 8 yards per person per year, which is indicated with the sort of horizontal red line here. That only occurs in the early part of the 20th century, but really about 2 decades after deindustrialization has occurred in East Africa. So again, this suggests, well, it cannot be about cloth imports alone. So already by the first year of my PhD, I really knew I had to look for something else here, and I started this sort of adventure into local conditions to try to understand how various local conditions in different parts of sub-Saharan Africa, both in East Africa but also in West Africa, may have been interacting with these global or other external forces to produce really different outcomes when these areas were being confronted with global forces. But of course, to do this, if you want to look at local conditions, you have to do a lot of case studies. And so this was really the meat of the dissertation for the later years of my research. But of course, to do these case studies, I needed a lot more material. It's not just about numbers, it's not just quantitative. We also need qualitative sources as well to really understand what's going on the ground. So for example, I consulted merchant correspondences and had a lot of fun with a lot of very complicated handwriting. So I came to appreciate modern calligraphy. Also consular reports, which detailed a lot of trade developments in various parts of sub-Saharan Africa. And of course, the numerous books written by missionaries, by early researchers in sub-Saharan Africa, which also provided a great deal of information on village life and economic development in sub-Saharan Africa. So I did a number of case studies, but given the time constraints of this talk, I'm only going to share one with you to give you a sort of taste for how these local and global conditions might interact to produce deindustrialization in a way that's quite different than these dependency theories suggest. So the case I'm going to share with you comes from the Lower Shire Valley and what is today Malawi, which you can see here in the map if you are not up on your African geography. So what's going on here? In the Lower Shire Valley, there is the development of textile manufacturing from about the 16th century onward. This is not only production for local consumption, but it's also being regionally exported as far as Mozambique. So this is really quite substantial. But by the 1870s, all of a sudden, this thriving textile industry starts to rapidly disappear. What essentially happens is people in this region start to shift their labor away from industry, and instead they focus principally, for the first time in the valley's history, on producing agricultural goods, not only to feed themselves, but also to export to Europe. So what is going on here? What is causing this? Is this indeed simply the local industry being destroyed by imports from abroad? Or is something else going on here? Surprise, surprise, I will tell you something else is going on. So what exactly happens here? Well, first of all, to prove again that cloth imports are not causing this, we see in the red box this very kind of rapid period of industrial decline that occurs in the Lower Shire Valley. And we can see that it happens way before there is a massive rise of imports, which really occurs decades later. So this really cannot be explained, by these forces of globalization coming in and crushing the little guy. This has a lot more to do with the way that individuals, that families, that households actually choose to allocate their labor based on changing circumstances and really thinking through economic rationality for themselves. So what happens in the Lower Shire Valley is this region undergoes a series of pretty rapid and in some ways really catastrophic changes that completely alters the sort of household calculus and affects the way that people choose to allocate their labor. So first of all, in the 1860s and into the 1870s, this particular region is really plagued by violent, large-scale slave raiding, which is being carried out to actually create slave labor on islands in the Indian Ocean to feed global demand for certain raw materials, particularly cloves. So people are being pulled out of this region to begin with. And secondly, this creates a huge amount of disruption of village life. This together creates horrible famine conditions, which kills off a huge percentage of the valley's population. Some estimate even as much as 90%. That's probably an overestimation, but still it is quite significant. So the sort of famous Scottish explorer, David Livingstone, who had visited the region many times, reported in 1865 on really the catastrophic consequences of this slave raiding, and he said, the riverbanks, once so populous, were all silent. An oppressive stillness was reigning where formerly crowds of eager sellers appeared with the various products of their industry. Labor, he tells us, had been swept away from the Great Shire Valley. Now, this is very important because when we're talking about handloom textile production, this is extremely labor intensive. It takes a great deal of effort to produce these products. So if we're seeing a decline in labor, that's already going to have an impact on the local textile industry. But there's something else going on at almost exactly the same time. And this is really kind of by chance, it's unrelated. Because of certain environmental changes occurring in the region, there is a massive decline in the river levels of the Shire River, which runs immediately through the valley. Now, this is important because when river levels drop, fertile wetlands are revealed for cultivation. So this means that this region suddenly gets a huge amount of very, very fertile farmland that can be used to produce agricultural goods. So if we, and you can see here the Shire River actually running through the valley, and in the kind of stripy lines, this is the development of these fertile wetlands that people can begin using. So these two events taken together lead to what we as economic historians or economists would call a shift in factor endowments. So here what we're seeing is that this region suddenly is having a lot more land relative to a decline in population. So more land relative to labor. And this shift creates a context in which it simply makes a lot more economic sense for households to choose to apply their diminished labor to agricultural production to actually take advantage of this rise in global demand for products that can be produced here. So this, I argue, is the reason that people choose to stop producing textiles and instead focus their labor on agricultural production. So this is very much an agency question. These are people really making choices within a shifting context in their local communities. So this is just one example. I could give you many, many more, but I think everybody has a lovely evening that they would like to get to. But the sort of takeaway message here is that deindustrialization theories, whether they be on the left, on the right, they tend to focus on global market forces. And this really leaves out local conditions and local decision making, which really differs actually from place to place and from case to case. Competition from imports, I think I have very clearly shown with this dissertation, they don't explain what's going on here. It's not just about global market forces. There is a lot more at play here. But to uncover what's going on, we need more case studies, which I am a big fan of. So in carrying out these case studies, I was able to sort of complicate the model and show that there are a number of local structural conditions that were actually interacting with these global forces to produce really different outcomes, not only within East Africa, but also in West Africa as well. I've talked a bit about the environment here and the labor force, but you can see that there are many other factors that come into play depending on the case study that you are looking at. And I will say that things get much more interesting when we compare cases of industrial decline in East Africa with cases of industrial resilience in West Africa, which is what I do in the final dissertation chapter. But given time constraints, I encourage you to pick up a copy of the dissertation to find out, or if you would like, please get in touch with me for comments, questions, whatever. I love to talk about this topic, so I would love to have a chat. So thank you very much, and well, I will exit the stage.
Thank you very much for, well, undermining things that we take for granted. I think that's an important type of result. And I'm not sure whether anyone else knows, but the Keetje Hodshon Prize, is this the first time the prize goes to someone who has the name Keetje, more or less? It sounds almost predestined, but there are local circumstances. Yeah, of course, also thanks to Professor Eltinga for her words and handing over the prize. There's a third prize this afternoon, which is named after the Ruigrok Foundation, so Ruigrok Prize, already introduced. Broadly speaking, no, should I do this in English? Nee, niet nodig, geloof ik. We hebben de geesteswetenschap, trouwens nog een opmerking. Het is verrassend dat de geesteswetenschapprijs dit jaar naar Wageningen gaat. Ik bedoel, we denken aan universiteiten, die geesteswetenschappen, dat zijn vaak de brede oude universiteiten. En Wageningen is veel meer een, nou zoals de technische universiteiten, heel domeinspecifiek. Maar juist daar valt hij dit jaar. Dat vind ik ook wel gewoon een heel leuk bijkomende resultaat. Maar goed, naast de geesteswetenschappen, de gedragswetenschappen en de sociale wetenschappen. En daar hebben we de derde prijs. Dit jaar gaat hij voor op het terrein van psychologie. En de laudatio wordt door professor Haaghoort uit Nijmegen van het Donders Instituut en het Max Planck Instituut voorgedragen.
Yes, this is I will do this in Dutch, but first I will like to make a remark about the wonderful talks we've heard before from two wonderful minds. And especially I would mention to Professor Dr. Elam Fadali that the human mind is supported by a brain that's very energy efficient. We do our computations that a supercomputer does at 12 watt rather than at large numbers of megawatts. So it's in and of itself a remarkable phenomenon that we can do this so efficiently. And of course, we can maybe also learn something from it. Oké, dit gaat over de prijs voor de gedragswetenschappen. Samen met mijn andere juryleden, professor Harald Merkelbach van de Universiteit Maastricht en professor Patty Valkenburg van de Universiteit Amsterdam, hebben wij 24 voordrachten bekeken. Ik moet zeggen, dat was een substantiële hoeveelheid werk. Ik geloof ook dat er nooit eerder zoveel dissertaties voor deze prijs zijn ingediend. Maar dat was toch ook een heel plezierige werk, want er waren excellente dissertaties daaronder. Uiteindelijk hebben wij 5 dissertaties op de shortlist geplaatst en die uitvoerig met elkaar besproken. Maar gelukkig was de jury uiteindelijk in het beraad unaniem in het oordeel dat de Ruigrok-prijs 2023 moet worden toegekend aan dokter Michelle Achterberg voor haar baanbrekende dissertatie over de sociale emotieregulatie tijdens de kindertijd. Het dissertatieonderzoek van Michelle Achterberg is een echte tour de force, want in haar dissertatie combineert zij gedragsonderzoek met hersenmetingen bij kinderen en genetische informatie verkregen in tweelingonderzoek. En dat is op zichzelf al een buitengewone prestatie, want dat zijn heel verschillende onderzoeksmethoden die je moet combineren en waar je ook expertise op moet hebben ontwikkeld. Op het schoolplein en in sociale media worden kinderen vaak geconfronteerd met oordelen die andere kinderen over hen hebben. Deze sociale feedback heeft consequenties voor hun gedrag, onder andere voor de mate van agressie. Om dit gedrag goed en op gestandaardiseerde manier te kunnen meten, ontwikkelde Michelle Achterberg een ingenieuze taak, de zogenaamde Social Network Aggression taak, die aantoonde dat kinderen die werden buitengesloten of afgewezen aanzienlijk agressiever reageren dan kinderen die werden geaccepteerd. Er zijn echter duidelijk individuele verschillen in agressie-regulatie bij kinderen. Sommige kinderen zijn gevoeliger voor sociale afwijzing dan anderen. En vervolgens, en dat was het belangrijke ook van dit proefschrift, identificeerde dokter Achterberg in fMRI-onderzoek, dat onderzoek waarbij je gebruik maakt van complexe hersenscanningstechnieken om activiteiten in het brein te meten, welke hersengebieden bij de verwerking van sociale feedback betrokken zijn. Zij liet zien dat met name delen van de frontaalschors, en het voorste deel van onze hersenen, belangrijk zijn bij emotieregulatie. Dat is het onder controle brengen van emotioneel gedrag zoals agressie. In het pièce de résistance van het dissertatieonderzoek onderzocht Michelle Achterberg bij een cohort van 512 kinderen, en laat u even dat op zich inwerken hoeveel werk daarin gestoken is, in de leeftijd van 7 tot 11 jaar, hoe deze breinprocessen zich gedurende de kindertijd ontwikkelen. fMRI-onderzoek bij deze leeftijdsgroep is uiterst complex en vereiste dat dokter Achterberg voor haar onderzoek innovatieve methodologische vernieuwingen moest introduceren. En daarnaast is de longitudinale benadering bij dit type onderzoek tamelijk uniek, juist omdat het zo'n logistieke inspanning vereist. Allereerst vond zij dat agressie na sociale feedback afneemt tussen de vroege en de late kindertijd. Tevens toonde zij aan dat meer breinactivatie in de frontaalschors tijdens de late kindertijd was gerelateerd aan minder agressie en minder sociale afwijzing. Bovendien vond zij dat bij kinderen waarbij de relevante delen van de frontaalschors zich sneller ontwikkelen, ook een snellere ontwikkeling in de regulatie van hun sociale emoties te zien was. Met andere woorden, dit deel van de hersenen en de ontwikkeling daarvan levert een belangrijke bijdrage bij het onder controle brengen van je eigen agressie en eigen emoties. Vervolgens onderzocht zij in welke mate er voor deze regulatie belangrijke verbindingen met een frontaalschors onder genetische invloed tot stand komen. Gebruikmakend van onderzoek bij 2- en 1-eigen tweelingen kon zij laten zien welk percentage van de variatie in hersenactiviteit in de frontaalschors op een genetische basis berust. En dit bleek in de ordegrootte van 15% te zijn. Deze resultaten laten zien dat het verwerken van sociale feedback en het reguleren van emoties in de kindertijd worden beïnvloed door zowel genetica als omgeving. En dit werd in deze dissertatie heel nauwkeurig en heel specifiek aan elkaar getrokken en in kaart gebracht. De jury was niet alleen onder de indruk van de hoeveelheid werk en de diversiteit aan onderzoeksmethoden die in het proefschrift vertegenwoordigd zijn. Vooral was de jury onder de indruk van de coherentie van het onderzoeksprogramma, waarin op systematische wijze de samenhang tussen gedrag, hersenontwikkeling en hersenprocessen en de invloed van genetica en omgeving op de regulatie van sociale emoties bij kinderen is onderzocht. Hierdoor ontstaat een integraal beeld van sociale emotieregulatie in een belangrijke fase van ontwikkeling. En dat is niet alleen van eminent theoretisch belang, maar heeft ook grote maatschappelijke relevantie in een tijd waarin mede dankzij de sociale media sociale feedback alom tegenwoordig lijkt te zijn. De jury hoopt zeer dat de prijswinnaar dit unieke onderzoeksprogramma voortzet en de prijs als een belangrijke aanmoediging daarvoor ziet. Dank u wel.
Dank voor de laudatio. Helaas is de datum zodanig dat mevrouw Achterberg zelf niet aanwezig is, maar vertegenwoordigd wordt door iemand die met haar gewerkt heeft, begrijp ik, Simone Dobbelaar. Ja? Wilt u dan hier komen en nogmaals professor Elsinga om...
Ja. Nou, het is mooi, heel mooi om het laudatio te horen. Toeval wil dat ik in de commissie zat om dit proefschrift te beoordelen destijds. Dus ik kan me helemaal vinden in... ik was ook diep onder de indruk destijds van het proefschrift en ook de verdediging was geweldig. En ja, wat ook bijzonder is, we zien vandaag 3 vrouwen op rij deze prijs ontvangen. Ik denk dat mag wel even genoemd worden. Dat betekent in ieder geval dat er geen bias is geweest in de mensen die hebben voorgedragen, in de commissies die er over hun hoofd hebben gebogen. Dus nou, dat is een goed teken. De wetenschap gaat de goede kant op, zou ik zeggen. Mooi. Ik denk velen met ons, ja. En voor dit onderzoek, bij een promotietraject lijkt 4 jaar lang, maar dat is het eigenlijk helemaal niet. En dat denk ik wat eigenlijk al deze 3 prijswinnaars laten zien, dat zij in staat zijn geweest om in die 4 jaar echt iets te doen waarmee echt substantiële bijdrage wordt geleverd aan de kennis. Op hele verschillende gebieden, dat zei het al, van de nanometers naar Afrika, tot de complexiteit van een adolescenten- of een kinderbrein, maar de complexiteit is eigenlijk even groot. En ook Michelle Achterberg, kijk jou maar even aan als vervanger, dat is haar ook echt gelukt. Met dat enorme sample, om dat in de tijd te volgen, tweelingen daarbij te betrekken. En inderdaad ook nog de relevantie van dit onderwerp, die feedback waar jongeren mee te maken hebben op dit moment en ook de enorme problemen die er op dit moment zijn met jongeren, met name ook dat we zien na de coronapandemie, dat het welzijn toch echt heel veel slechter gaat, is dit heel erg belangrijk onderzoek waar we nog veel meer van willen zien. Ja, helaas, Michelle die zit in het vliegtuig op dit moment, begreep ik, dus die heeft het heel goed geregeld en de volgende generatie staat al klaar. Dus dat is heel erg mooi. Ik neem aan dat jij een beetje in het verlengde ook onderzoek doet. Dus nou, je kan er vast een beetje mee profiteren. Dan wil ik jou de 3e prijs overhandigen. Voor Michelle Achterberg, de Ruigrok Prijs 2023. presentatie van Michelle Achterberg online, begrijp ik, hè? Ja. Die taak hoef je niet op te nemen. Oké, ga lekker zitten.
Hi everyone, my name is Michelle Achtsberg and I'm a developmental neuroscientist and assistant professor at Erasmus University of Rotterdam. Unfortunately, I'm unable to attend this festive ceremony in person today, but I'm grateful for the opportunity to virtually present my work. I feel very honored to receive the Johannes Cornelis Ruigrok Prijs. I'm passionate about the brain and how underlying neural mechanisms can help us understand psychological and behavioral processes in developing children. I'm beyond excited and proud that my neurodevelopmental findings are so highly valued in the field of behavioral sciences that they are awarded with this beautiful recognition from the Koninklijke Hollandse Maatschappij der Wetenschappen. Therefore, I would like to thank the J.C. Ruigrok Stichting, the KHMW, the jury, and all who made this possible. Before I talk about my findings and my research line, I would like to take the opportunity to thank a few more people. First and foremost, I want to take this opportunity to thank my wonderful supervisors, Anna van Dijvervoorde and Evelien Krone, with whom I wouldn't have been able to put all this work together. Besides the scientific work, I value their mentorship, which have been a big inspiration for me to pursue a own academic career. Specifically, Eveline's vision that collaboration is more important than competition has been of great importance to my own view of science, as I truly believe in team science, and specifically with regards to neuroimaging studies, which require strong teamwork. Therefore, I would also like to thank all the members of the Leiden Consortium on Individual Development and the Society Youth and Neuroscience Connected Lab for the enthusiasm and inspiration every day. I want to specifically mention Simone Dobelaar, who is here with you today. She was my first PhD student and I greatly enjoyed to work on our studies together. Being able to become a mentor myself and work together on our research has been a great blessing. Last, I would like to thank my colleagues from the Department of Psychology, Education and Child Studies, and specifically Professor Loes Keizers for providing me with the opportunity to continue my research as an assistant professor at Erasmus University Rotterdam. So you now might wonder, what is that research about? And I'm very happy to share my findings and some of my future plans with you today. So the leading question that drives me in my research is, why are some children more sensitive to social evaluations than others? And I try to answer this question by using a developmental perspective, focusing on childhood and emerging adolescence. So childhood, and specifically middle to late childhood, is the phase in life when the first long-lasting friendships emerge. So dealing with social feedback, such as social acceptance and rejection, it's an important prerequisite for developing and maintaining social relations. Some children just shrug after a child rejects them on the playground. They keep their head high and they just move on. However, other children get really frustrated and use reactive aggression after they receive negative feedback. But what determines how a child reacts? And how come that some 9-year-olds behave more adult-like than others? We think this might be due to individual differences in developmental trajectories of social emotional regulation. And in my research, I try to unravel these mechanisms. To experimentally examine social emotional regulation in childhood, I developed a new task, the social network aggression task. So prior to the lab visit, children fill in a personal profile with questions such as, what is your biggest wish? And during the scan, they see pictures of unknown pairs with social feedback towards their profile. And this can either be positive with a green thumb up, negative with a red thumb down, or neutral, which is depicted by a circle. After the feedback event, children get the opportunity to react towards the pair that judged them by blasting a loud noise, like this. And children can choose themselves whether they want to blast a short, soft sound or a long, a hard sound. In the past 6 years, we've done several studies using this paradigm, both in children as well as in adults. And behaviorally, we find strong effects in different samples that all show that negative feedback leads to the most aggression. Moreover, these cross-sectional studies show that older participants differentiate more between conditions, so the differences between the conditions becomes more pronounced. Also, using longitudinal analysis in children aged 7 to 8 and 2 years later, 9 to 11, we saw that children show more behavioral control, specifically for behavioral responses after positive social feedback, suggesting that children start to differentiate between the conditions more, so you see steeper slopes. And to test whether these between individual effects are also detectable within an individual across time, we wanted to use the SNOT in a longitudinal design. And we did so in the LSIT project. The Leiden Consortium on Individual Development study includes two different cohorts, the early childhood cohort, age 3 to 5 at wave 1, and the middle childhood cohort, age 7 to 9 at wave 1. Each cohort has 6 annual measures, and across the 6 waves, home and lab visits are alternated. The home visits include behavioral measures, and lab visits additionally include a neuroimaging measure, which is EEG or MRI. The last 2 waves of the early childhood cohort overlap with the first 2 waves of the middle childhood cohort, resulting in a cohort sequential design including children aged 3 to 14 years old. All participants in this study are same-sex twins, and approximately 55% of the sample is monozygotic. To experimentally examine social enrichment, we included an intervention between the second and third measurements. 40% of the sample received the video feedback intervention to promote positive parenting and sensitive discipline. Data collection was still going on at the start of the COVID-19 pandemic, so in both cohorts, we included measures specific to the pandemic in an additional COVID-19 wave. Using this longitudinal design, I was able to study social development across childhood. And on a group average, I showed differential developmental patterns of dealing with social feedback. Aggression following neutral feedback showed a gradual decline across development, whereas aggression following rejection first showed a peak, possibly showing a sensitive window for dealing with social rejection during late childhood. Additionally, I was able to show a direct link between brain development and aggression regulation. The dorsolateral prefrontal cortex, here depicted in yellow, is often involved in cognitive and behavioral control. We discovered that children with larger developmental increases in dorsolateral prefrontal cortex activation, so here depicted on the x-axis, showed larger developmental decreases in aggression following social rejection. And these results show that childhood might be an important period to study individual differences in dealing with social rejection, as there is rapid social development both in terms of behavior as in the brain. The unique design of LSIT, where we combine longitudinal neuroimaging with a twin design, provides us the opportunity to also investigate heritability and environmental factors. If we look at behavior aggression, we found that 10% of the variation was explained by heritability. 8% was explained by shared environmental factors, such as parenting, for example, and the remaining 82% of variation was explained by unique environmental factors. For dorsolateral prefrontal cortex activation, 40% of the variation was heritable and 86% was explained by unique environment. Thus, variation in aggression in dorsolateral prefrontal cortex activation is explained by heritability and the environment. So what I hope to show you is that strong development in social emotional regulation during childhood and emerging adolescence. Activation in the dorsolateral prefrontal cortex has repeatedly been shown to be related to the level of aggression regulation following social rejection. And this is not just a trait, this is something that develops across this age span, as we found that increases in brain activation across 2 years were related to decreases in aggression following social rejection. Our behavioral genetic analysis showed that majority of the variation in both behavioral and brain responses to social rejection were explained by the environment. As brain development and environmental influences are thus of influence for the development of social emotional regulation, childhood might serve as a window of opportunity for adolescent social behavior. And for me, the next step is to investigate this theory in more depth. Therefore, I developed a neurodevelopmental environmental model of social development. And this model states that individual differences in biological determinants, such as brain development and heritability, and environmental influences, such as parents and peers, across childhood moderate the association between day-to-day social interactions and well-being in adolescence. And in the near future, I want to extend the existing LSIT data set with a fourth wave of brain imaging when the participants are 15 to 17 years old. By re-inviting participants that have been followed since they were 7 years old, I can test the theoretical model using a decade of longitudinal brain data. Moreover, I also want to examine how dynamic social interactions are related to well-being by studying real-time social interactions of adolescents using experience sampling methods. And by combining MRI and experience sampling methods, we can move the field of developmental science towards a more fine-grained understanding of how neural activity in a lab setting is related to social experiences in the day-to-day lives of adolescents. With society becoming increasingly socially complex and challenging, it's more important than ever to understand individual differences in dealing with social rejection. So besides fundamentally examining these underlying mechanisms, I also want to share my scientific findings broadly to really make an impact in society as well. It is my vision that sharing these kind of knowledges on the importance of dealing with social rejection can change the dominant beliefs and ideologies in society, such that there will be more recognition, and this time, effort, and education on fostering social development in children and adolescents. One way in which I would like to do so is by developing an e-learning program, which will provide teachers with the necessary means to teach children about social development. As social rejection is one of the most challenging experiences in a child's social world, I strongly believe that we should educate children on these social development. Psychoeducation on why rejection can hurt so much, and that the majority of youth experiences difficulties with dealing with social rejection, can ensure youth that it's okay to sometimes just have an off day. The JC Ruigrok Prijs will provide me with the financial means to professionalize this e-learning and make it widely and freely accessible for teachers. So thank you again for this wonderful recognition and the opportunity to present my work. If you have any questions or if you would like to discuss collaborations, please feel free to contact me. I wish you all a very pleasant and festive afternoon and of course a sunny summer holiday. Thank you.
So I hope that all the people at home got a good lesson in Dutch, but they all got to understand your presentation. So that's wonderful. We come to the end of this session, but before you go, I'd like to invite the 3 prize winners, including Simone as a proxy to a prize winner, to the front, because Ad and Wim still have something to give you. So would you please come up here? Because traditionally, the Koninklijke Hollandse Maatschappij der Wetenschappen would give not a check, which they didn't have in the 18th century as we do now, but they would give a medal. And we are going to give you the traditional medal of the Koninklijke Hollandse Maatschappij. Now, to make sure that your expectations don't rise too high, they used to be gold. They no longer are. But imagine that was the only way they got paid for all the time and the effort they put into work. For you, it's just to commemorate this day and to celebrate the wonderful work you've done in your thesis. Ad and Wim, could you hand them out to
Definitely.
all 3?
I can do that. With pleasure.
Your name is engraved on the side. That's why we had to make sure that you got the right one. And of course, because we are in Holland, flowers to go with it. Now, everybody who is not in het bestuur... Ik ga weer terug naar het Nederlands. Bestuur van de Ruigrok Stichting wil ik graag uitnodigen om hierbij te komen om wat foto's te maken. Geldt ook voor de juryleden die hier zijn. En alle anderen krijgen een voorsprong om naar de borrel te gaan die in de bestuurskamer is. Dank u wel voor uw aanwezigheid en nog 1 keer een applaus voor deze prijswinnaars.
Yeah.